you weren't here Friday, I encourage you to go back and watch that recording. It's like maybe 15 minutes at the most. But I did go through two important formulas, how to find magnitude and how to find direction. So C, this is another way to show vector, okay? The I is your horizontal component, J is your vertical component. So to write this in component form, it would be 3, -4. And remember, vectors, the bracket is pointed. So now let's find our magnitude. So this is your delta X. This is your delta Y. So the magnitude is the square root of your delta X squared plus delta Y squared. Oh, excuse me. Thank you. All right, go ahead and figure out what that is. That's actually a perfect square. That 3, 4, 5. But so you should get 5. And your direction, that's the inverse tangent of, it's always tangent, delta Y over delta X. Go ahead and type that in your calculator. Now, the only thing we need to worry about is our direction. So let's go back to our component form. Yes. Yes, in the box that says formulas to know, it's because those are formulas you need to know because they won't be given to you. There's a few more that'll be coming also. Okay, what quadrant? Show me with your fingers. What quadrant is this? Positive X, negative Y. Yeah, quadrant 4, which means that I need for this to fall between 270 and 360 because this is in Q4. So what do you think I'm adding to that? It's either 180 or 360. How much do I need to add to get to a number between 270 and 360? Do I need to add 180 or do I need to add 360? Pick up your calculator and try it. If you take negative 53.13 and you add 180, is that enough? If not, then try 360. So what I get was 306.87 degrees. That is my magnitude and my direction. Any questions about C? All right, so again, that is vector form. When you look at question D, again, -2, that is my horizontal component. Negative square root of 3 is my vertical component. That's component form. This is delta X, this is delta Y. All right, go ahead and find your magnitude first. And we can leave that in square root form. So I had square root 7 for my magnitude. Anybody else get that? All right. And then for my direction, inverse tangent, negative root 3 over negative 2. I got 40.893. All right, so right here, this direction that we came up with is in this quadrant. All right, 40 is in quadrant 1. But show me with your fingers, where is x negative and y negative? What quadrant are we in? Yeah, so what we need to do is reflect it. I need to reflect it. So how many degrees do you think I'm adding to that? It's not a full circle. How much am I adding? 180. Quadrant 3, your angles need to be between 180 and 270. So when you add the 180, we get our direction is 220.893 degrees. And that is it. Any questions? All right, page 3, we got some more formulas to know. Formulas that you will not be provided, but you need to know. Go ahead and copy that in that box. So what we're doing here is finding our vertical component and our horizontal component. So when I'm trying to find my horizontal component, I take the magnitude times the cosine of the direction. But for the vertical component, which is delta y, I take the magnitude times the sine of your direction. So this time we're going backwards. At first, we had our vertical and horizontal component, and we had to find magnitude and direction. This time, they're giving us magnitude and direction, and they want us to find the horizontal and vertical component. So a couple of things. This here, you see these double brackets? These double brackets, those are the brackets that signify magnitude. So what this is saying is the magnitude of vector W. That's how you would say that in English. If you were to translate this from math to English, it would be magnitude of vector W is 7. The direction is 20. So we got to find our horizontal component. So that's going to be the magnitude times the cosine of 20. And our vertical component is going to be 7 times the sine of 20. Go ahead and type that in your calculator. Round it out to the thousandths place. And that is it. So we have 7 cosine 20, 7 sine 20. So when I did it, this is what I got. Is that what you got? All right, do example 3 by yourself. Example 3, find your horizontal and vertical component. Magnitude of vector W is 11. Direction is 57. Okay, you all should be done. Did you get my answer? I got 5.991 for my horizontal component and 9.225 for my vertical component. Who had that? Any questions about that? All right, now let's talk about operations with vectors. So this is vector V. That's the horizontal and vertical component of vector V. Vector W, horizontal, vertical component of vector W. This is just saying multiply vector W by -5. That's what that's telling me to do. -5. I'm only using vector W. So you're distributing. And your final answer should be -15, +20. That's it. So notice that I only use vector W for part A. I did not need to use vector V. For question B, I need to use both. So for question B, B says take 4 and multiply 4 times W. And there's a couple ways you could do this one, but the way I did it was I multiplied this parentheses by a +4, and not parentheses, sorry. I multiplied the first vector by +4 and the second vector by -1. And then I added them. That's what I did. So if I multiply the first one by +4, that would be 12, -16. Bring down your addition sign. Now I'm changing it to addition because I'm multiplying by -1. Now you don't have to do that. You can just leave it as subtraction and subtract. But I like to change mine to addition. So I'm going to flip the sign. And now you're ready to add together your horizontal components, which would give me a 6, and your vertical components, which give me a -10. And that's it. It's that simple. That's what I got. All right, let's look at example 2. Go ahead and multiply the first one by 3 and the second one by 2. I'm going to freeze my screen. You do yours, and we'll come together to see if we agree. Who agrees with my answer? All right, good. Now you could do question B 2 different ways, but notice that this is the same vector. So let's just pretend for a minute that this wasn't vectors. It was just variables. If it was 2V minus 5V, what would you say that equaled? What is 2V minus 5V? -3V. So you can do this in one step. Instead of multiplying it twice, you could just take -3 times vector v. Now, if you didn't do it that way, if you multiplied vector v by 2, and then you multiplied it by -5, and then you add it, you're still going to get the same horizontal and vertical component. So if you don't recognize that on the test, that you can combine your like terms, that's okay. You don't have to. You'll still get the same answer. All right, I feel like you all are doing pretty good with this, so I'm going to go to the next page. I'm going to skip over a couple of these, though. I'm going to skip A, and let's just do examples B and C. Now you're using 3 different vectors. So this one says take vector F. Vector F is 7, -1. And then add to that 3 times vector G. And then add to that 5 times vector H. All right, go ahead and multiply and simplify. See what you get. I'll put the answer for A just in case somebody wants to do it. Okay, who got what I got? 38, -5. All right, go ahead and do C. Do C. All right. I don't remember doing this fifth period, but did you all get 6244? So what I did, again, anytime I have a subtraction, I like to just include that. I distributed a negative and changed it to addition. All right, so let's go ahead. This is the same thing. When you're multiplying, that means you're changing the magnitude and not the direction. What we are just doing is called scaling a vector. That's what we just did. So if I multiply vector v, so this is my vector v, by 2, that just means I've scaled that vector by a factor of 2. So the last part of 9-4, and then we will be finished with 9-4, is determining if a point is on the path of a vector. So another formula you should know, go ahead and copy this down. So we're going to write a set of equations. In order to do that, I need to know where it starts, what point does the vector start at, and I need to know the change in x and the change in y. And we're using that information to find a point on the path. So the first thing I need to do is write my set of equations. So this would represent my x1 and my y1. Okay, so x of s, all right, that's going to equal x1. x1 is 1 plus, what is my delta x? Delta x is 3. Now, I don't really like to use the letter S because it looks like a 5, so try to make sure you don't confuse your S's with 5s. So that would be my first equation. Somebody want to volunteer what you think the second equation would be using y1 and delta y? What's y1? 2. What's delta y? All right, that would be my equation. So these are the equations that will tell me points on the path, okay? So what we need to do is to find 2 points on the path. You need to choose any number. So you can choose any number from negative infinity to infinity to substitute in for x and y, to substitute in both equations. So, Aaliyah, give me a number, any number. 4. All right, let's substitute in 4. So if s is 4, all right, if I choose s equals 4, that means my x value will be 1 plus 3 times 4, and my y value will be 2 plus 5 times 4. Go ahead and simplify that down to get your order pair. These are 2 numbers. So you got to take 1 plus 3 times 4, 2 times 5 times 4. So I substituted the number that Aaliyah gave me. I substituted into my equation right here in place of s. So find a point on the path. This tells me that the point 13, 22 is on the path. That is an actual point on the path of the vector. Okay, Makara, give me another number. Any number? 6. All right, let's do 6. I want everybody to substitute it in to see what would your order pair be if S is 6. And you could pick any number. It doesn't have to be positive. It could be a negative number. It could be 0. Any number. So that's why when you're doing your homework, question 6, everyone should have different answers. Because nobody's picking the exact same numbers. All right, this is what I came up with. I got 1932. Anybody get that? All right, last question. Part B. So now they gave me an ordered pair, and they want us to figure out if it's on the path. So the way we do that is I substitute in each equation and solve it for S. Now, if F is the same, then it's on the path. Okay, so I'll give you a moment to copy that down, and then we will see. We are going to see if that point is on the path. So what I need to do is I need to plug in, I'm going to substitute in the 7. 7, I'm going to put the 7 right here. So I want you to solve the equation 7. So I'm using this equation. I'm using both of these equations. So let's put the 7 here. So 7 equals 1 plus 3s. We're going to solve that. And then we're going to do the same thing with the y. I'm going to put the negative 8. I'm going to put that here. So negative 8 equals 2 plus 5s. All right, solve that for S. If you get the same number on the red and the green, then the answer is yes. The point 7, negative 8 is on the path. But if you don't, that means that it's not on the path of the vector. So again, let me recap that. They gave me a point, and I need to figure out if it's on the path. Substitute that x into your x equation. Substitute the y value of the coordinate into your y equation and solve them both for S. If you get the same number, the answer is yes. All right, who got the same number? I got a 2 and a negative 2. Is that the same? No, I got two different numbers. 2 is not the same as negative 2. So the answer is no. No. The point 7, negative 8 is not on the path. All right, that's it for today. You can finish all of homework 17. Homework 17 is due Thursday. We got a skills check Friday, a skills check Tuesday, and a test next Friday.